Good morning, and thanks for joining us today in our series of webinars that at this point, I'm hoping it's getting to start to being familiar for you. My name is Luca Gattubiggio. I'm part of ELSEC as a cloud program manager and innovation manager. And my focus is mostly in the cloud. So today, I'm glad to continue our webinar, as I just stated, trying to explain specific topics that hopefully will help you better understand how to get the first steps in the cloud and how to improve anything that you might already have in the cloud. This series of webinars, of course, is part of our project called OpenCloudification. Our main website is opencloudification.com, and there you can find anything related to the project that we're trying to develop for the upcoming years, and all the events and everything that we are gonna organize from now until the end of the projects. Some new additions that might be worth it to mention are the sandbox environment that we recently introduced, in which you can basically get access to some resources and physically play with some Kubernetes clusters. Don't forget to visit also our main website, elsec.eu, in which you can also get an idea of all the other projects that we are currently running and all the future idea, together with all our members and partners that can help you related to cybersecurity. So let's get started with the webinar. Today, we're gonna talk about orchestration, and more in the specific, we're gonna look at some of the configurations, advantages, and challenges that we might face in terms of hybrid and multi-cloud configurations, so hybrid and multi-cloud settings. And in that sense, we will also look a bit into what are the best practices for moving from a single cloud. And from single cloud, I mean either a public cloud provider, so whether you already have someone handling your cloud publicly, or your own cloud that might be a private cloud or a private hosted cloud by a third party. Then delving a bit into the orchestration, we're going to focus a bit on infrastructure as code, because it's an important aspect of orchestration. And as a last step, we're going to look at the security concerns and challenges that we might have introducing a new orchestrator, especially in more advanced configurations. Today is going to be mostly a theoretical webinar, and the reason for that is that we are also planning to organize some more hands-on sessions that we are probably going to announce in the upcoming weeks, and by the end of the summer, or probably at the beginning of September, October, we are going to have more information about it. So make sure to keep following us and get all the news from our website and our channels. So let's start with the first topic, hybrid and multi-cloud configurations. We're gonna deal a bit into what is a hybrid and a multi-cloud configuration, what are the definitions that we can find. There isn't a clear definition of hybrid and multi-cloud, so I'm gonna try to explain a bit how this works. What are the advantages that we might get, and what are the reasons behind thinking about a hybrid or a multi-cloud configuration? And of course, what are the challenges that come along with that? And at the end, I would like to introduce some relevant definitions or keywords and some of the industry trends that are currently hot topics in terms of hybrid and multi-cloud configurations. So we start with hybrid cloud. One of the most acknowledged definition of hybrid cloud is that we're talking about a composition of 2 or more clouds. And generally speaking, when we're talking about hybrid in the specific, probably we are including a private cloud. So it's a combination of private cloud plus 1 or more public cloud. And in that sense, usually a private cloud is something that you have within your own firewall or within your own premises. But sometimes can be also considered a private cloud, anything that you are the only organization that you have access to without sharing the resources with anyone else. While multi-cloud, it is generally referred to the adoption of 2 or more public cloud only. But sometimes, and with public cloud, of course, I'm talking about the main ones, but generally speaking, anything that is publicly available as Azure, AWS, Google Cloud, IBM, Alibaba, and so on. But even the minor cloud and the third-party providers that maybe build their own cloud on top of the public cloud providers or on top of open source solutions. But as I was saying, there isn't a clear definition of that. So sometimes you might still hear multi-cloud as a definition for something that it also involves your own private cloud. And at the same way, you can find definitions that says that a hybrid cloud is just a combination of multiple clouds, no matter from where they come. One reasonable question could be, why should I consider to move to a hybrid or a multi-cloud solution? Why shouldn't I stick with my single cloud, or why shouldn't I stay within my data center in my organization? So these are 3 separate surveys that have been with questions that have been asked in the last 2-3 years. Maybe the right scale, the bottom right survey is a bit older, but still you can get an idea of the percentages of companies, IT companies in this case, that are already using multi-cloud. And as you can see, the great majority, they're already on multi-cloud settings, multi-cloud operations. And in some of them, as you can see, it's just multi-cloud as a aggregation of hybrid or multiple public or multiple private, which is a bit less common. But in general, all the IT companies that already are working in the cloud prefer to get a multi-cloud setting. What are some of the advantages? I tried to separate hybrid and multi-cloud, but a lot of advantages and challenges especially will somehow overlap. So I'm trying to distinguish here, but more or less the advantages in this case are for both senses and in both directions. With a hybrid cloud, you have the flexibility of scalability for the different workloads in the sense that as long as you can manage, for example, to run all your workload within your cloud, you don't have to use a public cloud. But at the moment that you have a peak, or for any reason you would like to have a boost on your resources, you can always rely on the public cloud. And that also helps with the cost control, because you will only pay for these extra resources that you need. And in the same sense, the scalability for computing power or storaging or networking or anything can be leveraged from the cloud side, from the public cloud side. The main advantage, by the way, is the fact that you're more secure in the sense that all the data that you will consider as sensitive will and can remain within your infrastructure. So you don't have to move the data towards the cloud. While in a multi-cloud setup, yeah, of course, you have even more flexibilities because you have the possibility to choose between multiple cloud providers, and you can switch them as you need for any reason. Generally speaking, the main reason would be reducing the cost that you might incur in spinning some new resources. So you're able to pick the cloud provider that offers more competitive prices, for example. But it's also, and it also reduced the vendor lock-in, the famous vendor lock-in issue, which is the fact that you won't be stuck with a specific cloud provider because you can always move everything from one cloud to another one. And since you have access to multiple cloud, then you will probably have multiple regions and multiple zones. So that's also enhanced performances in one sense, but reliability mostly in the other hand. And of course, since some cloud providers can offer specific solutions, you might facilitate your innovation in the sense that you can get access to all the different features that only specific cloud might offer. But as I said, together with the advantages, you will also get a lot of challenges. In this sense, it's a bit more mixed between hybrid and multi-cloud. The main concern would be that this type of settings will increase the complexity and the performances of your network. The challenges at least, because you need to have into the consideration the fact that you will securely connect several clouds, for example, that they will need to probably exchange data and information. So whether it is from your private cloud or between multiple clouds, you have to set up additional communication channels. And since the locations might be an issue, you also have to be sure that you will comply with data regulations. And depending on where the data centers or the availability zones are placed, you might need to set up specific policies for that. Also, since you're having now a bigger attack surface, you also need to make sure that you're securing all the different clouds separately and together. So it's also difficult to manage and monitor everything that's happening in several clouds instead of just one. Okay, now we move a bit more into the direction of cloud orchestration. And I think two main subtopics, let's call them, are the coordination and the automation part, because as cloud orchestration, I like this definition that is given here. It's a process of coordinating tools, but also application, APIs, infrastructure, resources, I would add, across private and public clouds into a comprehensive workflows. So what we're trying to do with orchestration is coordinate everything that you have access to and possibly automate it as much as possible. So those two subjects are extremely important, I would say are essential, because they will reduce, the automation part will reduce the human error and the manual tasks. So it will also speed up the process of deploying something or managing something in the cloud. It will improve, therefore, the efficiency and the productivity of your applications, for example. But what you have to make sure is to have one single pane of glass, as they define it. So one single entity that allows you to monitor everything that's happening, because that also helps with the management and the monitoring of your entire workflow. And with automation and coordination, so with orchestration in general, it will be easier to innovate and create something more agile, because you will have faster deployment, faster management, faster policies, faster applications in the end. And it will also help you with the compliance and governance settings. So while you're coordinating and automating your workflow, especially in multi-cloud or hybrid cloud, you will have to make sure that you're improving the efficiency and the reliability of your entire system. Because in the end, the bigger it's getting, the more difficult it is to maintain it, especially over time. And since automation is a part that will focus on specific tasks, the orchestration then would be this set of automation tasks that you will streamline somehow in your IT processes. To give an example for both the configurations, while you're orchestrating a multi-cloud environment, some examples might be that you will implement a specific platform that is usually defined as cloud management platform and the cloud brokerage. I will explain a bit what these two sentences or these two definitions mean. Or you will use a specific cloud resource to orchestrate as a specific framework. And something very similar also applies to an hybrid cloud environment, which you will probably also might have access to a third-party orchestration platform. So to do that, I think it's important to describe some of the main keywords that you will hear me talk about for the rest of the presentation. And I think the main one is infrastructure as code, because the more we're introducing complexity, the more we need orchestration. And the infrastructure as code concept or model is a big part of the orchestration. The idea, without going into the actual definition, is that we are treating our infrastructure exactly as we treat any other type of code. And therefore, we're bringing a lot of advantages that are usually applied to code management and code lifecycle. And we're defining by writing an entire infrastructure as just one page of code. And when I'm talking about, and when you will hear me talking about cloud agnostic solutions, we're referring to all those designs or strategies that involve the fact that no matter where you're deploying it, you will able to move it, for example, from one cloud to another without too many difficulties, I'd say, because it's difficult to have a cloud agnostic solution that can be immediately moved from one place to another. There are some little caveat that you have still to twist a bit. But a good example is containerization. In that sense, the use of container is defined as a good way, a good cloud agnostic solution, because a Kubernetes cluster can be deployed in Amazon, can be deployed in Microsoft, in Google, in your own cloud, in your own Kubernetes cluster, and more or less the way to do this deployment remains the same. Two other topics two other concepts that will be used during the presentation are the environment as a service. This is a new way of defining, since now we're basically defining everything as a service. Imagine the environment as a service as an automated way of deploying infrastructure or services to run your own application, or in your DevOps procedures, maybe to test on a specific setup without the need for the engineers to manually deploy it, but have like some sort of pre-made environment that you can just click and deploy it. This is a service that it's offered as a service by companies, or that your own company can a bit organized and have it like internally, for example, for your test environments or for your production environments. While the cloud management platform that I already partially mentioned it is a specific platform that helps you with the orchestration in the broad term. So we're talking about monitoring, control, automation, and it is related to your entire cloud environment. So resources, services, anything that goes through several clouds. So we're not talking about one specific cloud, but generally they offer solutions that are able to connect in a multi-cloud fashion or in a hybrid cloud setup. And what usually happens is that this cloud management platform has its own separate space. So you will probably access directly the cloud management platform, and the platform itself on your behalf will then deploy in the various cloud all the resources that you might need. Most of them are making use of infrastructure as code, but this is not necessarily the case. Some other concepts, some other industry trends that we see happening more and more. There's some focus now on the sustainability and carbon intelligent cloud. See this more as a green way of having your own cloud. This is something that maybe we can explain a bit more in another topic, because now we're going a bit out of topic in this sense. But it's something that we see increasing, like companies are starting to get an interest in also the sustainability of having a lot of resources deployed in the cloud, for example. Another big concept is the cloud infrastructure and platform service automated programmable infrastructure. So basically, it was I was saying as the environment as a service or infrastructure as code. While you have something that it's automated, you just click and you will have deployed an entire environment for you. And the containerization technologies are Kubernetes as a top container orchestrator as the main cloud agnostic solutions that we can find at the moment. So we've seen more or less what are the hybrid and multi-cloud setups. I would like to go a bit more in deep into some of the best practices or the advices that you can get while you would like to move from your single cloud to a more complex environment. We discussed a bit what are the advantages. What we will see are some of the best practices that you can consider. These are still high-level best practices because, of course, each situation is different. So it's not that easy to define a specific procedure that can help you moving from a single cloud to a multi-cloud, for example. But we will see some of the cloud designs, or I will try to explain a bit what are the differences, and then some of the relevant aspects that you should still consider. So as we said, the main reason I'd say is the vendor lock-in. If you're using one single cloud, you're basically locked with the specific cloud provider. This is I'm referring to a public cloud setup in which anything that happens within the cloud, if you have everything deployed there, you're basically stuck with them. You can reach a point in which it's too late to move everything because your application keeps growing, for example. But then say that your cloud provider is suddenly doubling the prices, there's not that much that you can do. While in a multi-cloud or in a hybrid cloud, you can always get your resources and move them somewhere else. Data sovereignty, of course, in this sense, especially in the hybrid cloud, if you don't want sensitive data to be stored or moved towards the cloud, you can always keep it on premises. The security aspect is still something that might be considered. You might not be sure, you might have concerns that a specific cloud provider is not secure enough for your data. So maybe you would like to move to somewhere else, or again, you would like to keep some of the data within your private cloud. So the security aspects are still reasonable to consider. And of course, if you already have some sort of investments that coming from previous models, or you have still a functioning data center, why not combine it with a public cloud to enhance it, for example? And so what should you do as some of the preliminary steps if you would like to get to a hybrid or a multi-cloud? Well, first of all, you should decide whether you want a hybrid or a multi-cloud. But in general, the very first step is to assess what you currently have. So having an idea of what's your current cloud environment, trying to understand how your application works on it, what are the dependencies, how linked you are to a specific cloud, what are the performances, what are the current costs, and then you can evaluate if it's worth it to move to another setup, like a hybrid cloud solution. And then you will define your cloud strategy, because that's something, as I said, that it's really specific to each use case. And in that sense, you should outline immediately what is the strategy before starting the transformation, as they sometimes call it, because it's important to have all the steps clear since the beginning, because problems might always happen, things might change, people can change, they can change idea, and so on. So it's better to have a clear overview of the entire process and have a precise strategy while you would like to move to another setting. You will have to identify the business and the technical requirements, of course. So you will have to understand what are your technical requirements that you need from this new transformation to the cloud. What are the advantages? What are the services that you might need? And then select the cloud providers themselves. Like if you're with your own cloud, you will have to pick what is the best among the public cloud services available. So as we said, assess and choose, those are the first two best practices that I would define to do. Basically, those are still part of the preliminary steps. But then it's important to have a design of what you would like to have as a final result from this transformation. And designing the cloud architecture is a complex step. We mentioned in some of the previous webinars the concept of well-architected framework, for example. So in that sense, all the main cloud providers, if I'm not mistaken, are offering some guidance even when you're deploying something that is defined as multi-cloud. So even if you're considering other cloud service providers, they have documentation that might guide you a bit on designing your entire cloud. You might include a cloud management platform. So you will have a centralized way to manage, but also to see and monitor everything that is happening in your entire ecosystem. And then you will have to define a cloud secure strategy that in a way that you're sure that you're compliant, that you're protecting your data and you're preventing all the potential threats that might happen, especially now that you're in a multi-cloud or in a hybrid cloud solution. And the monitoring and everything related to controlling what's happening in your cloud, that's probably something that we are gonna take as a separate webinar, because there's a lot to say there, and it's important also for several aspects, not only for hybrid and multi-cloud solutions. So we'll probably talk later in one of the upcoming webinars. So if you pick an hybrid cloud design, there are, as I said, there are multiple ways of define hybrid cloud. I found this image quite interesting, as they're showing that there's not only the private and public cloud as connection for a hybrid cloud, but sometimes your data center is still outside what you would consider as your private cloud. So there's this sort of triangle between private, public, and data center, but also the connection between your private cloud or your data center and multiple public cloud. In that sense, you also have to consider all the potential connection and how you would like them to communicate to each other, because increasing the number of clouds also increases a lot the complexity of the networking. What are the main reasons to choose an hybrid cloud instead of a multi-cloud? Well, as I said, keep the data within your private cloud, so you avoid a lot of concerns related to data security. You want to migrate to the cloud in the sense that you have a legacy application, for example, but you would like to use some of the advantages that are coming from public cloud providers, but it's still difficult to move your entire application because, for example, it's a legacy app which has a monolithic structure and cannot be immediately moved, especially in a multi-cloud setup. You would like to migrate just part of the workload to the public cloud, or you would just like to use part of the resources as extra resources for testing or research purposes. The multi-cloud design, on the other hand, it's a bit more complex. There isn't like a specific definition on or a specific way to define how you should design your architecture. I found these 6 different multi-cloud designs that were explained on this website. I found them interesting. Some of them I don't even know exactly what they mean. With cloudification, okay, for example, you're moving your entire app and probably define it as microservices, so somehow splitting your app and moving towards several clouds. But there are also a lot of configurations that take part of your applications. They consider, for example, the use of a load balancer. They consider relocate the entire application as in a lift and shift model, while you're moving everything to one cloud, but then you're using, for example, the user interface on another one, the storage in another one, and so on. So there are several ways. There isn't the good one. What we constantly see, and what I focusing here, is the use of a cloud broker, or as I defined it earlier, the management platform that helps you with the entire management of your multi-cloud settings. And in this sense, this is, I think, the image that more or less represents best what I'm talking about. So as you can see, I hope you can see my cursor. You're always including some sort of external broker, which can be managed by you or can be managed by a third party. And this broker will usually handle part of the services that are connected to other clouds on your behalf. And in that sense, your application can still be managed separately and communicate through other channels. But what I see most of the time happen is that you will use the broker service to also deploy the different parts of your application on the multiple clouds. Okay, so you're doing this transformation. There are some additional concerns, I would say. We will talk a bit more in detail later on the security aspect mostly. But three main subjects about this transformation is that the data management and the integration will be way more complex. In most of the cases, you would like to sync everything that is happening in your entire cloud, which means that there has to be a lot of communication to sync up what's going on between the different areas of your cloud, which means in terms that the network connectivity is extremely important and way more complex because you have to set up all the different way to communicate for those different clouds, which also means that there are security concerns and you still have to comply with all the different cloud policies, for example. Another important aspect is that in the end, you're moving to a multi-cloud, for example, with the idea of deploying your application. So you should also consider all the DevOps aspects that are related to having now this new, more functional, with more advantages type of configuration. So while you're implementing this transformation, you should also consider all the relevant aspects that are related to the DevOps processes. And in that sense, some of them are related to what we already discussed. So have a CMP and a cloud broker. But you will also would like to have a centralized code repository, because this is a centralized way to have full control on what's happening in the different branches, let's go, of the cloud. The use of container is highly suggested because it's part of the DevOps procedure, and it's also cloud agnostic. So that also helps with this type of approach. You should, as I said, integrate it with your own cloud strategy. Try to get as much as possible the knowledge and the policies that are part of your team so you can better define and design the type of final configuration that you would like, especially if you have teams that are more specialized on some of the components that just one type of cloud can offer, for example. You will probably have to adjust a bit your tooling for DevOps for the multi-cloud. And again, as an important reminder, keep the monitoring, the observability, the logging, everything related to the possibility to check what's going on within your entire cloud. Okay. I think it's time to finally go into the orchestration part, because that's the actual topic of today. I found another definition. This is a definition of orchestration given by Cloudify, which is a tool that helps you with the orchestration of clouds. Part of it is open source, as in there's a free version that involves the use of Terraform only, and then it becomes a premium version with some extra features. But still, they define the cloud orchestration as something that refers to the arrangement and the coordination of automated tasks, and that will result in a consolidated process or workflow. So again, we're talking of coordinate, automate, and consolidate everything as a workflow. This is just a reminder of what I've been saying already. Maybe it's better to define different types of orchestrators, because orchestrator might be considered a broad term. So I would like to split those based on what we're gonna discuss more in the specific. What I mean is that if we're talking about hybrid cloud solutions, what usually happens is that you're connecting your own private cloud with just a public cloud, just one. That's the main case. And in that sense, the public cloud provider will probably have, like 99% of the times, will have its own orchestrator that can help you with the configuration, with the setup and the managing of this new hybrid cloud. AWS, Azure, but also Google, all the main cloud service providers have this sort of vendor type of orchestrator that you can use. There are advantages and disadvantages in that sense. If you're using a specific cloud orchestrator that comes from one of the vendors, it will have advantages because probably it will have more functionalities for its own cloud. And they're moving in the direction, at least some of them, of being able to orchestrate also something that happens on other clouds. But this is more a scenario in which you're building your hybrid cloud or a single cloud, like just with the public cloud, and you're mainly staying within it. While orchestrator that orchestrate infrastructure or resources more in general, they will probably use infrastructure as code. In this sense, I'm referring mostly to Terraform, which is one of the main open source solutions that you can find made by HashiCorp, but also other solutions like Pulumi, for example, is a good alternative to Terraform. This can be more indicated for multi-cloud, but of course, no one stops you from using them in a single cloud. A lot of them have connection for Kubernetes as well, so you can also manage containers. And I think it's also important to mention that still the vendor ones, most of them are still using infrastructure as code anyway. And the last section, the last type of orchestrator, which is a separate type of orchestrator, is more focused on the containers than I'm talking about Kubernetes or Docker that probably everyone knows. Those are more on the cloud agnostic solution. I would consider it for containers only. And in that sense, again, we're not going to talk about those. We're not going to talk about Kubernetes today because probably we will have a specific webinar for it. So as I said, for example, AWS CloudFormation, which is the orchestrator for AWS, but together with that, we're basically mentioning all the vendors orchestrator. They use infrastructure as code, and in their case, they will, for the AWS case, you will manage AWS infrastructure, but as I said, they're also moving towards different type of clouds that they can still manage. There's, for example, an ongoing collaboration with OpenStack. So both the orchestrator from AWS and OpenStack can manage resources from the other cloud. That's something that's been going on for a while, and I'm sure that now they're even increasing the amount of resources of the clouds that they can manage. What they do is to provide this simple and consistent way to provision everything that can be provisioned or updated. And I'm talking about resources, networking, but also policies, containers. You're defining a stack, which is your collection of resources and all the dependencies connected to each other. And basically, through this, you will deploy everything without going through all the different services that otherwise you will have to go through. So you can, as I said, define a wide range of resources from compute instances to storage, networking, but also security groups, policies, and so on. Most of them support the concept of change set. So what you can do is preview what's going to happen. So you will see what are the changes before making them. This also helps you avoid issues that might occur if you wouldn't be able to check what's going on until you did it. So in that sense, you will mitigate the risk of propagate some sort of error that otherwise you wouldn't notice, because the change set will show you what are the difference between the current configuration and what you're trying to change or add or remove. And as I was saying, they integrate with other services. The vendor orchestrator, of course, mostly integrate all the services that are available within their own cloud. But in general, they're including more and more services every day. So now you can also deploy serverless that I didn't mention already as an example. Some of them have specific features like the parameterization, conditionals, the use of loops. One of the open source tools that I mentioned allows you to write everything choosing your own programming language. So it's actually writing proper code still to deploy your infrastructure. But these are different examples and different functionalities that some of them have. And of course, there's the entire integration with all the DevOps and all the CI/CD tools. So you want a seamless integration in a way that every update might trigger a new configuration, and new configuration might deploy something new that goes within your pipeline. So you keep the loop and include the orchestration as part of it. You will enable the infrastructure provisioning. That's the main thing of using infrastructure as code, of course. I didn't mention yet, but I think I'm gonna discuss it quite soon, that with infrastructure as code, you have all the advantages that you have while you manage your code. With that, I mean having consistencies because you have version control, basically. You can automate the process because once you wrote a specific piece of code that deploys on your environment one deployment, you can reuse the same code, for example, to respin new resources that deploy again the same infrastructure. So maybe you want to have one deployment that is your test environment, and if that works, redeploy exactly the same thing for production environment. You will manage complex architecture. The infrastructure goes across different environments. It's just for multi-cloud, so that's part of its functionalities. The managing of resources is simplified. As I said, you have everything through the orchestrator. You don't have to go through the different services that you will otherwise need to go through in the deployment. In this sense, just a brief example. Let's say you want to deploy on AWS a virtual machine. So what you would do is maybe you want a specific virtual private network. And so you go to the networking service and you deploy and you create your private network. Then you want to use to deploy on it your virtual machine. So you will go to the virtual machine service and deploy it. And then you will have to set up some policies for connection or firewalling, security groups, and so on. So you will go to that specific service and do that. With infrastructure as code, you just write those different lines of code and you will have it deployed because the orchestrator will then communicate with all these services. This is even more complex while you would like to have something that it's part deployed in AWS, part deployed in Azure, for example. This is just a reminder of what I've been saying about infrastructure as code and what are the cloud agnostic solutions. We already seen this, so I'm going to skip, because the idea is to then check more what are the orchestrators that use infrastructure as code. Like, let's go a bit more into details on what they can provide. Part of them I already mentioned, so consistency and reproducibility, because then, as I said, while you would like to deploy in different environments, you can reuse the same code as long as it works. and it's validated, there's no need to change it. You can reuse it, and you're sure that you're not including any new mistake. So you're spinning up different resources at different stages, in different environments, and you will avoid what is called configuration drift, or at least will try to minimize what are the introduction of inconsistencies, because you're reusing it. And since it is code, you can use the same advantages like the version control. So you have always a look through the various changes that you made. You can keep track of those. And if something at a certain point goes wrong, you can always revert to the previous version in a way that you can also collaborate with your teams, and they might make changes is exactly as you would treat code. This process can be automated. That's part of the orchestration in general that makes it way more efficient, because, as I said, you will reduce the manual effort of go through all the different services, which might also involve some human errors on that. So the infrastructure becomes something that is automated, and you don't have to, I mean, you still have to take care and consider and being concerned that security issues might be there, but the human factor is way less important. It becomes faster to deploy for exactly the same reason. And of course, it can take advantage of all the scalability and elasticity solutions that you can use through the various multi-cloud providers. Try to go a bit faster because, yeah, I understand there's a lot of a lot of definitions that I'm just throwing at you. In the same sense, the auditing and the compliance are improved because you can check and you can keep track of the changes. You can check that your code or your infrastructure, which is the same thing, is correct. The changes can be tracked. You can use tools and solutions that help you with the check of the writing of your code. So you're making sure that is written properly. It can be used for disaster recovery and resilience because that's part of the capabilities of any orchestrator. The definition of your infrastructure as code can be more portable and more what they call vendor agnostic or cloud agnostic in some extent, because yeah, there are minimum changes that you could make. Since you're writing code, what will probably change are some of the specific definition for the specific cloud provider, but the rest of the code remains the same. Part of the CI/CD integration that I already said. And of course, it's some sort of documentation that constantly show, and it's an actual document that you can use and you can refer to check whether your infrastructure is on the state that you would like it to be. This is a very, very simple example of how you would write, an infrastructure as code configuration file. In this case, this is from Terraform, which has a slightly different language to write the code, but you can always use either JSON or YAML. And in this case, you can see how easy it is to tell that I would like to deploy something on AWS, and I can even specify what region I would like to have. The virtual private, this is the network, the subnet that I'm defining here, just putting some instruction on how to call it, for example. Those are variables that I can also include in my code. defining the instance. And in this case, for example, what is very specific is that I am picking the image that from AWS is called AMI or AMI, and connecting to the specific subnet that I just defined. And then you continue, you put storage like an S3 bucket and so on. So this is more or less an idea. But as I said, we will probably have more hands-on session on that. So you will also get a better idea on how to deploy something using an orchestrator that makes use of infrastructure as code. Okay, the last section of this webinar will focus a bit more on the security of your cloud orchestrator, but in general of your new setup. We've been discussing in one of the last webinars about the security of your cloud in general. And in that sense, we were defining mostly different levels of responsibility based on your model, which is like having an infrastructure as a service, a platform as a service, or a software as a service might bring different type of responsibilities shared, especially between you as organization and the cloud service provider. And if you're going for a multi-cloud or a hybrid cloud, probably you're focusing mostly on the infrastructure as a service or a platform as a service. Something that I didn't mention is that sometimes in some of the definition of hybrid cloud, it is also included while your private cloud is just a Kubernetes cluster. Because to some extent, it can be seen as a cloud itself. It isn't, because it's more a platform. But it is true that a lot of functionalities can be interconnected with the public cloud or with another cloud. So it still makes sense to consider hybrid as a combination of a Kubernetes cluster and AWS, for example. So most of the cases, while you're having an hybrid or a multi-cloud, you're probably having an entire infrastructure that you control, or at least the platform. So those are the best practices that we discussed in the last webinar, where those are, let's say, more general, high-level processes that you would like to manage and you would like to make sure to have your cloud secure. This comes from the Cloud Security Alliance guidelines. In that sense, I'll quickly just go through them. You will have to identify all the security and compliance requirements for the existing controls that you have. You will have to select your cloud provider, the services, and the deployment models. Twisting my tongue. You will define the architecture, assess the security control, identify if there are gaps, design and implement the controls to fill these gaps, and then manage the changes that might happen over time. So this is still applicable while you're having an hybrid or a multi-cloud configuration, but of course it will bring some additional security challenges, because as we've been saying, data now is more complex to manage since it's spread across multiple cloud providers and also on your on-premises infrastructure probably, which means that you need to ensure that the encryption, the access control, the data, anything related to the data that are becoming more challenging are still in place for all the environments. So the data classification, all the data loss prevention measures, for example, are still need to be implemented everywhere, because you have to protect the sensitive information everywhere. Then, of course, it's easier if we're still considering the hybrid solution, in which you will probably just keep everything that is sensitive in your own cloud, but then you have to make it secure. There are risks related to the interoperability and the integration between the different cloud platforms, especially when you're also connecting your own systems to the cloud. So while you're also including on-premises infrastructure. In that sense, a lot of misconfigurations or vulnerabilities can be exploited. So it is dangerous that one vulnerability in one of the cloud can be exploited, especially if then this will allow the attackers to have access to the entire multi-cloud, which is usually difficult, but still might happen. So you have to make sure that you're putting in place all the integration, the secure integration practices. You have to secure your APIs because most of the cloud will communicate through APIs. And of course, you will keep test as much as possible to try to mitigate these risks. The attack surface is necessarily increased because now you have more entry points, not only for your applications, but also for attackers. And so since sometimes each cloud might have its own unique set of security considerations and its own vulnerabilities, as I was saying before, you will have to assess and secure all of them for each cloud environment. And then you will have to manage identities, access controls, and in this case, across the multiple cloud platforms. A good idea, and this is again something that we already mentioned in the previous webinars, is the use of a centralized way of managing the access control. So an identity and access management service that can be centralized and can control basically everything, no matter which cloud the access is needed. The other big issue would be the network security challenges, because then you have to ensure that there are secure communication channels in place. Sometimes a VPN is enough, but you will also have to keep track and monitor everything that happens and look for anomalies, for example, to avoid that there are unauthorized access or data is moving or it is intercepted while it's moving, and so on. You will have to comply with all the different regulatory requirements that might be different for each cloud. So you have to assess each of them. Data residency and sovereignty, that's something that more or less I already mentioned about the different regional areas. So you have a geographical area, whether in some of them you might not be able to transfer data, or you have to take special considerations into. And the incident response and forensic, because of course accidents might still happen, incidents might still happen, and you would like to have plans in a way that you're sure of what are the specific procedures that you would take in case of any type of threat or any type of incident. Then you will have to conduct regular security assessment. You will have to ensure again the logging and the monitoring are active, and you're monitoring constantly what's going on in your services. So this is mostly on the configuration side, like on your setup, we're adding additional security concerns, but you're also, you will have to consider that now you have an orchestrator, and those might also raise some security concerns. In this sense, the main ones are the fact that the API might be vulnerable. Like your cloud orchestrators will probably communicate through APIs to allow the automation and the management of the resources. So it has to be extremely secure because it's acting on your behalf. So everything that you have access might pass through the orchestrator. could be an important target for attackers because they might get control and access to a lot of different resources that your orchestrator will have access to. And in that sense, you will have to make sure that API are secured, that there are in place strong authentication mechanisms, and then that you're constantly testing that everything is working as it is intended. And together with the fact that you're bringing advantages from the use of and treating your infrastructure as code, well, then you will have also all the disadvantages that comes using code. And in this case, you might be victim of code injection, because in the end, someone might try to modify your code to let you deploy something that you shouldn't. And in that sense, also template, because some orchestrators that are not directly using code will probably use templates, which is a similar concept. You're still stacking and defining the various resources that you would like to deploy, but they might also be tampered somehow. And then it's important to keep in place all the security aspects related to code or template in this case. So have a strict code validation, all the secure coding practices, and have reviews of your templates and the security of your templates in a way that you're preventing all those types of vulnerabilities. And another concern, of course, would be the data exposure and the leakage that you might have if you're wrongly configure some type of storage, for example, or databases. It might be the case that someone might gain access to it even when it's not allowed. Maybe you keep a port open that it shouldn't be open. The security controls aren't that strict, especially for authentication. There are several reasons. So what you would like to have in place are solutions like encrypt everything, make sure that configuration are secure for the storage in this case, check with all the vulnerability assessments and everything that is related and necessary to protect your data. There's an integration risk, of course, because you're integrating the cloud orchestrator with other services and other tools. So any vulnerabilities that might be happen can be spread to all the resources that it can reach. So you need to assess the security posture of all the integrated services as well, and make sure that all the security measures are in place. There might be insider threats or insider data exfiltration. This is also something that is not strictly related to the orchestrator itself, but of course, with the orchestrator is even more dangerous because, again, the orchestrator can have a lot of access. While we're using orchestrator that make use of infrastructure as code, then as I said, everything that is a vulnerability in code can also be a vulnerability in this type of orchestrators, because you're using code for provisioning your infrastructure. You need to make sure that you're able to store correctly and securely everything that is credential or secrets. And in that sense, you would also like to avoid to put sensitive data in your configurations file, for example. There's a misconfiguration risk, as I said, since you're automating the deployment, any misconfiguration that you put will be replicated in all the automation process. And there might be some security knowledges, lacks, and awareness in the sense that you still need to be aware of all the security practices and everything relating, in this case, to infrastructure as code. So it's also a matter of training and learning what these processes are, what are the best practices, and so on. The code itself, that now would be your infrastructure, has to be securely stored somewhere. Since we're using version control systems, well, that's most of the cases is Git, but it could be anywhere. So you need to make sure that only authorized people can actually access that data. Also, you might have sensitive information that you wouldn't even want to get out of the repository, such as the credential, the secrets, anything that shouldn't be, you shouldn't store it together with your code. Continuous monitoring and compliance, as I said, constantly checking for what's going on. That also applies to your infrastructure as code. There are dependencies that might come from third party, because you might rely on third party libraries, modules, frameworks. And in that sense, they might introduce risks that you're not even aware. So it's important to keep, for example, the updates, keep them maintained, and check if there are known vulnerabilities. And you will have to, of course, secure your entire development lifecycle, because this is not just part of the deployment, but it's also part, it starts from the design and follows through the development, the testing, and the deployment phases. Okay, so those are some of the best practices to do that. Basically, I already started commenting those while I was listing the issues. Use secure code and review your code, either for code in general, that's a general suggestion, but especially for your infrastructure as code. Keep secure your credentials and your secret. Check your configuration, validate it, tested it before using it. Most of the orchestrators allow these change sets that makes you see what's going on before doing it. So use it, test the frameworks, checks that all the security tools are in place, all the security procedures are in place, everything is validated before actually deploying something with your configuration. And of course, keep the security awareness within your team, train them to use the best practices and everything that comes new, be aware of all the new vulnerabilities and so on. Access control and permission that to allow everyone to have access only to what they should have access. Keep monitoring, keep auditing. I'm repeating myself at this point. The compliance and security policies should be in place. Make sure that everything is enforced as it should be. The entire life cycle should be secured, as I said, from design to deployment and maintenance. I would add, manage all the dependencies, especially when they're from third party. Check even there if there are vulnerability databases. Try to identify potential threats that might be there. Use tools for that. We discussed it, something similar recently as well. And last but not least, of course, collaboration, communication. All the different teams are now even more working together. I'm talking, for example, on the development, the operations team, the security teams. Since you're writing something that will impact all these teams or your entire organization, is important that you have collaboration between the various teams and give them all the security requirements that they might need and communicate through the various teams that everything that they should be aware of. Okay, this more or less concludes this webinar. Just a quick recap on what we've seen today. We started with the hybrid and multi-cloud configurations, more or less having an idea on what are the main advantages, what are the challenges of doing it, and why it makes sense or not. We delved a bit more deep in the best practices for moving from a single cloud to this new setup, this new environment. And then we finally talked about orchestration with a little focus on infrastructure as code, because as I said, is a big part of it. And finally, the new security concerns that comes from this new setup and the introduction of an orchestrator for your different configurations. I hope you're still with me. As I said at the beginning, and it's important maybe to repeat it now, this was mostly on the theoretical level, because what we are going to do in the upcoming months is probably have a hands-on or a workshop dedicated to also this concept. So we're gonna try to build something that you can actually put your hands on and work and see how an orchestrator works. This would be probably on the infrastructure as code type of orchestrator, but we will definitely also work for the Kubernetes one, for example, so the container one. With this, I would like to thank you, everyone that was still following. If there are questions, I can answer right now since we have a bit of time. Otherwise, this is my email. You can check for more information and for the slide that will appear on our website, OpenCloudification, for everything specific to this project and these topics, healthsec.eu for everything more general and to have a better look on everything that we do with all our different projects more related to cybersecurity, but not only. I would like to remind you that this webinar has been recorded, so you will also find the recording soon available for the future on the website. Thank you, everyone, and I hope I'll see you again in the upcoming webinars.